and welcome to instruction for general skill number 15. This is the law of cosines, and you'll find this in section 7.2 in our Blitzer text. There are three main things that we want to be able to do with law of cosines. The first thing is to be able to solve oblique triangles using the law of cosines. The second is to find the area of an oblique triangle using Heron's formula. And to do that, you're always given the side lengths of a triangle, or you have the means of finding the side lengths of a triangle. And then the last thing we would want to be able to do is solve application problems using the law of cosines. So we're going to jump in and find out, well, what is this thing that we call the law of cosines? So here we go. So the law of cosines is a relationship that we can see within an oblique triangle or any triangle. And we can derive that if we put an oblique triangle so that one side is along the positive x-axis, and then the other two sides extend from the vertices on the positive x-axis. Okay, so we're going to look and we're going to focus on this left-hand triangle. So if we look at this left-hand triangle, we can say that the sine of angle A is the same as y over b. Okay, we agree that the opposite of our hypotenuse gives us y over b. And then we can also say that if that is true, we can isolate y by saying that y is equal to b sine a. We can also look at the relationship of cosine of a, which then would be the adjacent side, x over the hypotenuse b. And then again, solve for x and say that x is equal to b cosine A. All right, so now let's focus our attention on the right-hand side, the right triangle formed on the right-hand side of this triangle. And we are going to think about using the Pythagorean theorem with this triangle. So if we do that, we are thinking about, now we know the Pythagorean theorem is a squared plus b squared equals c squared, but this triangle is not labeled in that way. We say a squared plus b squared equals c squared when c is our hypotenuse. And in this case, a is our hypotenuse. So we're going to look at y squared plus this side length squared will equal a squared. Okay, so now what is that side length? That is going to be the difference between c and x. So that kind of looks like this. C minus x squared plus y squared is equal to a squared. All right, so now we're going to go ahead and use some substitution and some algebra. Everywhere we see x in this formula, we're going to say where that's equal to b cosine A. And where we see y in this formula, we're going to say that that is b sine A. All right, so we've replaced those things, and now we're going to use a little algebra and square both of these expressions. Okay, so when we square this expression, notice it's a binomial, so that you're going to have to think of it as c minus b cosine A times c minus b cosine A. And when we expand that, we will get c squared minus 2bc cosine A plus b squared times cosine squared of A. And then this last piece is this last expression squared, where we square the b and we square the sine of a, b squared sine squared of a. Okay, so now we're going to clean this up a little bit because it's a little bit cumbersome. And so if you look at the right-hand side, actually the right-hand part of the right-hand side, we notice that there's a b squared in both of these terms. We're going to go ahead and factor that out. And when we factor it out, we're left with cosine squared of a plus sine squared of a, which you probably recognized as a Pythagorean identity. Sine squared of theta plus cosine squared of theta is equal to 1. So we can replace that whole thing with 1. And now let's just go ahead and get rid of the 1 and put this b squared over here with the c squared. And this is the most commonly used form of the law of cosines. And you notice that you've got in the front here a little bit of stuff that looks like the Pythagorean theorem, right? A squared is equal to b squared plus c squared minus 2bc cosine of a. So depending on what you're given in your triangle and how it's labeled, you can say it with those labels, or let's say that you're interested in solving for b. We can rearrange things so that the b squared is on this side, and if the b squared is on this side, and we want everything to align and the relationship to hold, notice that these two sides will be the same as these two sides, and the angle in between will be the last angle, okay? And so we can write the law of cosines in 3 different forms, and we're just going to use the form that applies to the case that we have. So there you go. That is the law of cosines. Now, when would you use the law of cosines? Well, since we've already talked about the law of sines, we're going to use that as much as we can. It's simpler and more efficient. And we will always use law of sines when we are given information that includes at least one side length and the opposite angle measure. So you've got to have a pair. The side length and the opposite angle measure must be present for us to use the law of sines. Now, when that doesn't happen, we're going to need the law of cosines. So that is used when we have information like we have 2 side lengths. For example, in this triangle, if you're given 2 side lengths and the measure of the included angle. So here we have 2 side lengths and the included angle. We call this an SAS triangle, side, angle, side, because we're given a side and an angle and a side, and that angle's in between. This is a great candidate for using law of cosines. Now, likewise, if you're given all 3 side lengths and no angle measures, this is also a great candidate for law of cosines, and we call that a side-side-side triangle. Okay, in the next video, we're going to run through an example of each of these types of triangles and solving them. And stay tuned and go into, let's say, video 2 of 4.